Welcome to the colorful world of Chapter 5, Part 1. Part 1, we're going to talk about shifting and scaling data. When we talk about shifting, we're talking about adding and subtracting. And when we talk about scaling, we're talking about multiplying and or dividing. But when I say dividing, I tend to think of dividing as multiplying by fractions, and I tend to think of subtracting as adding a negative. So we're just talking about adding and multiplying. Well, we need to think about our measures of position and measures of spread. And what am I talking about? Well, let's get a list going here. For measures of position, I'm talking about X bar, your mean. I'm talking about the median. I'm talking about Q1, Q3, the max. Those are all calculations or measures of position. They're talking about a specific location within the data set. Versus measures of spread are more or less, those are talking about distances. So who's a distance? Standard deviation of x is a distance. Interquartile range is a distance. Remember that this is Q3 minus Q1, so that's a distance. So you got standard deviation, sample standard deviation, IQR, and of course you have the range. Right? That's a distance. Range is max minus the min. Right? That's what the range is equal to. So let's continue to use that muffler data. We're going to squeeze all we can out of that muffler and brake shop. One last thing that I realized I forgot. A couple more measures of position. I forgot our minimum and maximum. Just thinking about that after I talked about the max versus minus min over here. So measures of position, measures of spread. Okay, now let's go to work. What I have listed here is what I consider to be the original values of all the data. $236.25 was my mean, so on and so forth. There's all the values. Now, what if we were to take all of the original list and multiply it by 3? What would happen? Well, you could do that. First, grab your calculator. Go to the home screen. That's the basic screen when you first turn on the calculator. And I want you to hit the second key and the number 1 so that you get L1 on your screen. So second L1. And then what I want you to do is I want you to hit multiply. So multiply times 3. And then I want you to hit the store button, which is just above the on button. It looks like STO with an arrow. And then I want you to store that in second L2. Enter. All right, so go ahead. L1 times 3, store in list 2. And as soon as you do that, what you should see is a little parentheses and then the number 168, blah, 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 blah. And if you go to Stat, Edit, and List 2, you'll notice that all of the values are there, and they should all be 3 times the value to the left. So 56 times 3 is 168. Now go ahead and run one variable statistics on List 2. So that's Stat Calc on L2. Run your one variable statistics, and then put all of those values in this list right here. What you should notice is that all of the values have tripled. All of the measures of position, right? X bar, min, Q1, median, Q3. That's a kind of a shady Q3. Q3, your max. Everybody's tripled. But also, most importantly, are your measures of spread. So let's just highlight those with a little pink box. Standard deviation, measure of spread. IQR, measure of spread. Range, measure of spread, right? Everybody else is a measure of position. Those 3 boxes, though, those represent distances. So what happens? If you triple the smallest number and you triple the biggest number, the distance between them will also triple. What about the adding? So let's go back to that home screen on your calculator again, and let's try the same trick. This time, L1 plus 10, and store that in L3. So go ahead, second L1 plus 3, store with the arrow in L3, enter, and the first number that you should see in your little parentheses there is 59, and of course, that was your original minimum, 56, plus 3, which is 59, then 91, 121. Now go ahead and run one variable stats, stat calc, one variable stats, on L3, and put all of that information in this column here. Now what do you notice is happening? My measures of position are all increasing by 3, so my min went from 56 to 59, Q3 went from 163 to 166, yada 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 for all the other measures of position. But your standard deviation is still 103.43. And for the IQR, I forgot to mention in this pink aisle here, you'd have to recalculate these by hand. My IQR is going to be the 305 minus the 166, Q3 minus Q1, which is still, hey, 139. And my max minus my min, which is 425 minus the 59, is still 366. So those stayed the same, those stayed the same. What are we trying to say here? That when you scale data, when you multiply, everybody changes by that multiplier. But when you shift data, when you just move to the left or to the right, distances don't change. Just think about that. Think about being the number 56 and being the max 422. If you add 3, think about them as little people. They all just sort of shift over to the right 3 steps. If everybody moves to the right or left 3 steps, does anybody get further apart from each other? No. Their value changes, but their distances don't. And that makes sense. With the scaling, when you multiply a small number, it grows by triple. When you multiply a big number, it grows by triple, but the distance between them gets drastically different. Let me show you a more concrete example of what I just said. Forget entire data sets. Let's just take the min and the max. If you multiply them both by 3, you're going to end up with 6 and 30. The distance between 2 and 10 was 8. The distance between 30 and 6 is 24. So distances change drastically when you multiply. But if you added 3 to 2, you would have gotten 5, and you add 3 to 10, you get 13. 13 minus 5, still 8. See? Shifting doesn't change distances. Scaling changes distances. So the big lesson here is when we multiply, everything changes by that multiplier. When we add or subtract, only the measures of position change. Now let's bring this into an application. I had attached a PDF file to the post with some handouts to work on. And the first one talks about students taking an introductory stats course, and the data that's provided over here refers to the number of credit hours. So the units on the values here is in hours. Now, the fee that the college charges for courses is $73 times a credit hour plus a flat student fee of $35 per quarter. So, for example, it says a student taking 12 credit hours would pay the $35 plus 75 times 12, or $911. What we'd like to know is, well, what's the mean fee paid? Well, we go over here and we take a look at X bar, right? That's our mean, right? X bar is 1665, and that's right here. So what are we going to do? This is a measure of position. So what's it going to get? It's going to get both treatments, the addition of the $35 and the scaling factor of 73. How do you apply it, Mr. Brecklin? You apply it in the same order as PEMDAS would dictate. First you multiply, then you add. So the mean fee would be $1,250.45. How about the standard deviation? Standard deviation, measure of spread. It is only going to get the scaling piece, the multiplier, not the $35. So our standard deviation in terms of credit hours is 296, and when you multiply that times 73, you get a standard deviation of cost, 216.08. So what did we do? We took our data, our summary statistics that was expressed in terms of hours, and now we can re-express all of those statistics in terms of dollars paid. Let's move on to median and IQR. What's the median amount charged? Again, median, measure of position, so it's going to get both the scaling and the shifting. 73 times 16 plus 35, 1203. What about the IQR for fees paid? Well, there's no IQR provided here. What do you have? You have your Q1 and Q3 given. So IQR is Q3 minus your Q1, which is 4 hours, or 19 minus 15 is 4 hours. And because IQR is a measure of spread or distance, it's only going to get the scaling. So 73 times 4 is 292. What is this saying really? It's 292. We're saying that the middle 50% of fees paid, the Q1 fee paid and the Q3 fee paid. The distance between those values is a spread of $292. That's it. It's a distance. Okay, now the last question is, 28 credits seems like a lot. Would you consider 28 hours to be unusually high? Now, unusually high is fancy for saying, do you think that 28 is an outlier? Now remember, an outlier defined in terms of our 5-number summary is Q3 plus 1.5 times IQR. That upper fence is the outlier cutoff. I'm not going to bother with the Q1 minus 1.5 IQR. That would be an outlier on the low end. So I would probably choose the minus 1.5 if they were asking me about, does 6 hours seem like unusually low? They were only asking me about unusually high. So I just want to assess what that is. Okay, well, we know IQR was 4 hours, and we know that Q3 was 19. So 19 plus 1.5 times 4, okay, gives us a value of 25. So is 28 high? Well, 25 is less than 28. So the answer to this question is yes. Anything over 25 hours is unusually high, and 28 is over that. So I consider it to be an outlier. That's that. You should now be able to handle the first portion of the other side of the PDF there, or practice C.